Now that we have discussed friction and its different types and formulas, we can talk about a special kind of friction, which is the drag force. The drag force is the friction exerted by fluids on the objects that are moving through them. And the simplest situation where we have a drag force is, for example, a falling body. We can see here in this picture we have a falling cat, and a drag force is exerted by the fluid surrounding this cat, which is in this situation simply air. So air molecules exert the drag force. And that's why sometimes we name the drag force as air resistance. It is exerted by air to resist the motion of this falling cat. We notice something in the free body diagram of the cat. As the fall starts, there is a weight force that is causing this fall for the cat, but at the beginning there is no drag force. But as the cat moves or falls further, the drag force emerges and it increases with time. However, in contrary to the friction force, where the friction increases as we increase the applied force, here we notice that the drag force is increasing, although the opposing force to it, which is weight in this situation, is still the same. This is because the drag force is affected by the speed of the object rather than the force that is causing the motion. And if we look at the formula for the drag force, we will see it has the following form: half rho, where rho is the density, CD, which is a constant, and it's the drag coefficient. It depends on the fluid that is surrounding this object. V is the speed of the object, so you can see here the drag force depends on the square of the speed. And A is the cross-sectional area of the body. Of course, this is the area perpendicular to the drag force. So if the object is falling, let's say if the cat is falling vertically, there will be a smaller area through which the drag force is flowing, and then there will be less drag force, while if the object was falling with a higher area that is perpendicular to the drag force, then the drag force will have a larger magnitude. And that's why parachutists open their parachutes as they are falling in air in order to increase the area of contact between the air molecules and themselves. And this way they will slow down more and more as they fall down. We can also consider here the situation where the drag force reaches a maximum. So the drag force cannot increase infinitely. It will reach a point where it reaches a maximum, above which it cannot increase. In this situation, it will be equal to the weight force. So the maximum drag force is going to be equal to the weight force in this example. And at this maximum drag force, the speed of the object will reach a constant value as well, because now the forces are canceling each other. So the speed of the object is going to be constant, and we can deduce it from the formula of the drag force. Since the drag is equal to the weight, then half rho CdV squared A is going to be equal to m times g. So we can get a formula for the speed of the object once the drag force reaches a maximum. And this value of the speed is called the terminal speed of our object. So this is a summary of what you're supposed to know on the drag force.